In this lesson, we will discuss Flight Controls Introduction, Controls and Indications, Flight Control Computers, and the ECAM Flight Control page. The A320 was the first commercial airliner to utilize a digital fly-by-wire flight control system. All flight control surfaces are electrically controlled and hydraulically actuated. This eliminates most of the traditional mechanical complexity and results in reduced weight, reduced maintenance costs, and increased reliability. It also provides optimum aircraft performance and improved fuel efficiency. Control surfaces on the A320 are conventional. Pitch control is achieved by two elevators mounted on a trimmable horizontal stabilizer. There are 5 spoiler panels and 1 aileron on each wing. Roll control is achieved by the ailerons and spoilers 2, 3, 4, and 5. In-flight speed brakes are provided by spoilers 2, 3, and 4, and ground spoilers are provided by all 5 spoiler panels on each wing. Yaw control is achieved by a one-piece rudder mounted on the vertical stabilizer. The trimmable horizontal stabilizer, or THS, and the rudder, in addition to electrical control, are mechanically linked to cockpit controls to provide a means of controlling the aircraft should a temporary, complete loss of electrical power occur. Each wing has 2 trailing edge flap surfaces and 5 leading edge slat surfaces that act as lift augmentation devices for takeoff and landing. The pitch trim wheels, flaps lever, speed brake lever, and rudder trim switch are located on the center pedestal. A set of rudder pedals are located at each pilot station. Note there is no aileron trim. Touch a control location to see an enlargement or the right arrow to continue. The flaps and slats position indicator is found on the upper ECAM display unit. Additional flight control information is found in the memo section. The traditional control column has been replaced by a side stick controller. The side stick, along with an auto trim system, enables the pilot to fly the aircraft more smoothly, with more precision and less effort, and provides a more comfortable ride for the passengers. Inputs from the side stick or from the autopilot are processed by the flight control computers, which command the control surface actuators to move as necessary. This system enhances flight safety by providing complete protection against flight outside the normal flight envelope and protects against stall, wind shear, overstress, and overspeed. The side stick controllers are located on the side consoles. Flight control is achieved by 3 types of computers, arranged to provide redundancy and failure protection. Different manufacturers, different hardware, and different software have been used to eliminate the potential for common errors. Electrical power sources are also from different electrical buses. There are 2 elevator aileron computers, or ELACs, for elevator stabilizer and aileron control. 3 spoiler elevator computers, or SECs, for normal spoilers control and standby elevator and stabilizer control. And 2 flight augmentation computers, or FACs, for electrical rudder control. 1 SEC, or 1 ELAC, is capable of controlling the aircraft in both the roll and pitch axis. The electronic flight control switches are located on the left and right sides of the overhead panel. The ECAM flight control page is displayed automatically with certain flight control faults and can be selected at any time with a flight control push-button switch on the ECAM control panel. The ECAM wheel page also duplicates the ground spoiler status. In this lesson, we have discussed Flight Controls Introduction, Controls and Indications, Flight Control Computers, and the ECAM Flight Control page. In this lesson, we will discuss side stick introduction and priority takeover. The two side sticks allow the pilots to control the aircraft manually in both pitch and roll. They are not linked mechanically, but simultaneous inputs by the captain and first officer are summed. The sum is limited to the maximum deflection by a single side stick. Dual inputs will cause both green side stick priority lights to flash and a continuous oral warning, dual input will sound. It is very important for both pilots to be clear about who has control of the aircraft. There is no direct feedback or artificial feel system, except for a simple spring centering device which neutralizes the side stick when it is released. On the ground, after the first engine is running, the side stick position indicators come into view on the PFD. They disappear when the aircraft is airborne. The white corner indices indicate the limit of side stick travel, while the white cross indicates the actual side stick order from both side sticks. This is useful for checking full side stick movement before takeoff, but does not indicate actual control surface position. For control checks, use the surface position indicators on the ECAM flight control page. The side stick has two switches, a dual-function autopilot disconnect priority takeover push button, and a communications push-to-talk switch. Whenever the autopilot is engaged, a solenoid-operated detent locks the side stick in the neutral position. If necessary, the detent can be overridden with sufficient pressure to unlock the side stick, which will also disconnect the autopilot. The normal method to disconnect the autopilot, however, is to press the autopilot disconnect push button on the side stick. A pilot can take full control and deactivate the other side stick by pressing and holding his priority takeover push button. If held for at least 40 seconds, the other side stick is latched out, and the priority takeover push button can be released without losing priority. Each time a side stick priority is taken, an audio message, priority left or priority right, is heard. Touch a priority takeover push button.
Please try again.
In addition, the side stick priority lights on the glare shield indicate which pilot has control. A red arrow in front of a pilot indicates his side stick has been deactivated and the other pilot has control. To reactivate a side stick, momentarily press its priority takeover push button. The last pilot to press and hold the priority takeover push button gets control. Note the first officer's side stick is not in the neutral position. Then touch the captain's side stick priority takeover push button to take control. A green light, either captain or first officer, is displayed in front of the pilot who has control when the deactivated side stick is not in the neutral position. If the deactivated side stick is released to neutral, the green light goes out, but the red arrow remains. Touch the first officer's side stick to release it to neutral. In this lesson, we will discuss pitch normal law, ground mode, flight mode, and flare mode. All aircraft fitted with fly-by-wire control systems have, within the flight control computers, control laws which determine how the aircraft flight control surfaces should be positioned at any given time. On the A320, normal law is active when all flight control surfaces function, even after certain flight control computer, hydraulic, or electrical faults. Protections are provided in flight, including load factor limitation, pitch attitude protection, angle of attack protection, high speed protection, bank angle protection, low energy warning, and load alleviation protection. Normal law encompasses 3 modes: ground mode, flight mode, and flare mode. On the ground, because sophisticated protections are not required, elevator deflection is in direct proportion to side-stick movement. Auto trim is not functional, allowing the pilots to set the trimmable horizontal stabilizer manually for takeoff to adjust for C of G variations. Ground mode allows the elevators to move to the max deflection of 30 degrees nose up and 15 degrees nose down in order to perform the pre-flight control check. Upon reaching 70 knots during the takeoff roll, max nose-up elevator deflection is reduced to 20 degrees to prevent the possibility of a tail strike at rotation. As soon as the aircraft becomes airborne, the transition to flight mode is blended in over a period of 5 seconds. In pitch normal law, with the side stick in the neutral position, the pitch demand is to maintain a constant 1g. This is the equivalent of maintaining a constant trajectory or flight path angle. Stick free, the elevator will be deflected in order to attempt to maintain constant trajectory through speed changes, changes in configuration, or atmospheric disturbances. Moving the side stick aft results in a demand for greater than 1g or positive g, and moving it forward results in a demand for less than 1g or negative g. Once the aircraft is flying the required trajectory or flight path angle, the side stick can be released to its neutral position and the aircraft will again maintain 1g. This means that it will maintain the new trajectory. Control inputs are made to alter or change the flight path, not to maintain it. Therefore, a side stick input can be considered as selecting a vector or vertical trajectory through space. Automatic pitch trim also operates in normal law. If a sustained elevator deflection is required to maintain trajectory during speed or configuration changes or to maintain a newly selected trajectory, auto trim will automatically reposition the stabilizer so that the elevator deflection with respect to the stabilizer can be reduced to 0, just as is done by pitch trimming a conventional aircraft during manual. In a turn of up to 33 degrees of bank, the pilot does not have to hold back pressure on the side stick to maintain altitude. Once the turn is established, the side stick can be released to neutral. As the aircraft descends through 50 feet for landing, flight mode changes to flare mode, a modified form of pitch normal law. The aircraft memorizes the pitch attitude at 50 feet, then at 30 feet begins to progressively reduce the pitch attitude to -2 degrees over a period of 8 seconds. The auto trim is also deactivated. This simulates the behavior of a conventional aircraft as it becomes influenced by ground effect and means that the pilot must apply a conventional flare technique, moving the side stick aft to achieve the correct landing attitude for touchdown. If a go-around is attempted below 50 feet, flight mode and therefore auto trim would not be restored until reaching 50 feet, and more than normal pitch force may be required to pull the aircraft up to and maintain the go-around attitude. Upon touchdown, elevator deflection is again restored to a direct elevator-side stick relationship. 5 seconds after touchdown, the trimmable horizontal stabilizer is automatically reset to 0 degrees. In this lesson, we have discussed pitch normal law, ground mode, flight mode, and flare mode. In this lesson, we will discuss bank angle protection and load alleviation function. The maximum bank angle that can be achieved is 67 degrees. Full lateral side stick must be applied and held. If the side stick is released, the aircraft will return to and maintain 33 degrees of bank. Beyond 33 degrees of bank, there is no pitch compensation. Aft control inputs would be required, as in a conventional aircraft, to maintain the desired pitch angle. The max bank angle of 67 degrees is indicated on the PFD by a pair of green bars. When the bank angle exceeds 45 degrees, the flight director bars disappear. The bank angle limitation of 67 degrees corresponds to the design G-factor limitation of 2.5 Gs. With flaps extended, the bank angle is limited to 60 degrees in level flight to correspond with the design factor limitation with flaps extended of 2 Gs. When high speed or angle of attack protection is active, the maximum bank angle with full sidestick deflection is reduced from 67 to 45 degrees. If the sidestick is released to neutral, the aircraft will return to wings level when high-speed protection is active, or to a maximum of 33 degrees of bank if high angle of attack protection is active. The load alleviation function, or LAF, reduces wing structure loads in conditions of turbulence by rapidly deflecting the ailerons and spoilers 4 and 5 symmetrically upwards when the aircraft load factor differs by 0.3 G compared to aircraft demanded load. To assist with the high hydraulic demands required, dedicated hydraulic accumulators are installed near the associated controls. LAF is inhibited with slats or flaps extended below 200 knots, or above VMO plus 10 knots. The load alleviation function operates in a degraded mode with associated failures. The LAF degraded message appears on the ECAM flight control page. With a total loss of the load alleviation function, LAF is displayed in the INOP systems column on the ECAM status page. In this lesson, we have discussed bank angle protection and load alleviation function. In this lesson, we will discuss slats flaps introduction, monitoring and control, slats flaps configurations, and ECAM abnormal indications. Each wing has 5 leading-edge slat surfaces and 2 trailing-edge flap surfaces. Slats and flaps are selected by a single flaps lever located on the center pedestal. Touch the flaps lever to select full flaps. Two dual-channel slat flap control computers, or SFCCs, monitor and control the slats and flaps. When a flap selection is made with the flaps lever, a signal is sent to the SFCCs, which in turn control the slats and flaps power control units, or PCUs. Each SFCC controls and monitors one motor of the flap PCU and one motor of the slat PCU. These hydraulic motors, through a mechanical system of shafts, gearboxes, and actuators, move the slats and flaps to the desired position. When the slats and flaps have reached their selected position, pressure-off brakes, or POBs, lock the hydraulic motors to prevent unwanted movement. With the failure of one of the associated hydraulic systems, or one of the SFCCs, the corresponding slats and/or flaps will operate at half speed. The SFCCs continuously monitor asymmetry position pickoff units, or APPUs, and feedback position pickoff units, or FPPUs, which measure slat flap position for asymmetry, runaway, uncommanded movement, and other failure conditions. If both SFCCs detect a failure, the wingtip brakes, or WTBs, lock the slats or flaps position and send a warning to the ECAM. Wingtip brakes, once activated, can only be reset on the ground. Two indication position pickoff units, or IPPUs, one for the slats and one for the flaps, send position data to the upper ECAM slats flaps position indicator. There is an interconnecting strut with flap attachment failure detection sensors between the inboard and outboard flaps. If a position difference is sensed, A signal is sent to one of the Landing Gear Control Interface Units, or LGCIUs, and the movement of the flaps is stopped by the pressure-off brakes. The flaps lever has 5 detents, 0, 1, 2, 3, and full, corresponding to the different slat flap configurations. Below the flap lever knob is a collar, which must be lifted in order to move the lever out of each detent. There is an internal balk between positions 1 and 2 and between positions 3 and full. To move past the balk, the collar must be released, then squeezed again, preventing an excessive 1 movement selection from full in the event of a go-around and from 2 to 0 during normal retraction. The flap indicator on the upper E-cam uses the shape of the wing to display slat flap configuration. A gray symbol represents the fixed wing center section, and the slats and flaps are represented by green boxes on either end of the wing. With the first flap selection, white points and an S and F appear to show the possible slat flap configurations. These are not visible when the aircraft is in a clean configuration. The selected flap position is shown in cyan below the gauge, and a blue symbol appears at the selected flap position. Flap movement is indicated by the green flap position indicator moving out toward the selected position. Once the flaps and slats reach the selected position, the selected surface position indication disappears, and the selected flap position indication turns to green. The chart shows the possible slat flap configurations. When config 1 is selected for takeoff on the ground, both slats and flaps extend. When config 1 is selected in flight, only the slats extend, and the flaps will then extend when the lever is selected to the config 2 position. After takeoff, with config 1 plus F, the flaps only will automatically retract at 210 knots to prevent exceeding the max flap extension speed of 215 knots. This may occur at high aircraft gross weights, where the slat retraction speed is close to 210 knots. After an automatic retraction, automatic re-extension does not occur if the speed again drops below 210 knots. When the flaps are extended, the ailerons droop 5 degrees. This position is indicated on the E-cam by an index on the aileron scale. If both associated hydraulic systems are inoperative, or there is a fault in the slats or flaps, the flap legend and the position indicators change to amber. The slats locked message or the flaps locked message is displayed with an E-cam caution when the wingtip brakes are engaged, or when there is an asymmetry condition between the slats or flaps. An alpha speed lock function prevents slat retraction at high angles of attack and low speeds to guard against stall. If angle of attack exceeds 8.5 degrees or the airspeed is less than 148 knots, slat retraction from position 1 to 0 is inhibited. When the flaps lever is moved from 1 to 0 under these conditions, the flaps only will retract. The slats will eventually retract when the speed increases to VLS for config 0. Note, slats do not automatically extend if pitch attitude is exceeded or if airspeed falls below 148 knots. In this lesson, we will discuss configuration safety check, cockpit geographic check, after start, before takeoff, takeoff, after takeoff check, descent, approach, landing, and after landing. When performing the configuration safety check, confirm on the upper E-cam flap position indicator that flap position is in agreement with the flaps lever. Also, check the position of the speed brake lever. If the flaps are not in the 0 position, or the speed brake lever is not in the retract position, contact maintenance. Do not apply hydraulic power or move any flight control surface without first obtaining maintenance clearance. During the cockpit geographic check, confirm that all flight control computer switch lights are out on the left and right overhead panels. On the glare shield panel, ensure both captain's and first officer's side stick priority lights are out. The pitch trim wheels should be at 0. They were reset to 0 at the last landing. Caution: never attempt to move the trim wheel without hydraulic pressure. On the center pedestal, again, ensure the speed brake lever is in the retract position and the flaps lever is in agreement with the ECAM flap position indicator. Normally, the flaps will be in the 0 retracted position. The rudder trim rotary switch should be centered. Push the reset button to ensure the rudder trim is zeroed and confirm the position indicator is 0 plus or minus 0.8 degrees. As part of the after-start recall scan flow, the captain selects the desired takeoff flap setting and arms the ground spoilers. Touch the flaps lever to select the takeoff flap, then touch the speed brake lever to arm the spoilers. The flap position is confirmed on the ECAM flap position indicator, and the message "Ground spoilers armed" appears in the memo section of the upper ECAM. If 2 minutes has elapsed since the second engine start, the takeoff memo appears indicating spoilers armed. Taxiing out, clear of congested areas, the captain calls for the before takeoff check. The first officer then initiates the flight control check. Movement of the side stick automatically brings up the ECAM flight control page. The first officer checks each control surface on the respective control position indicator, pausing momentarily to confirm full travel. This check includes the 5-degree aileron droop with the flaps extended. He also confirms full side stick movement by observing the limit indices on the PFD. Touch the side stick to perform the control check. The sequence is side stick left check, right check, forward check, aft check. Note: when moving the side stick during the control check, do not move the side stick any faster than required for an aggressive flight maneuver to minimize component wear. This is particularly important during extremely cold conditions. The first officer, after completing his portion of the flight control check, announces that he is ready for the rudder check, which is performed by the captain. The captain depresses the pedal disconnect button on the steering hand wheel, then moves the rudder pedals in both directions. The first officer, while following through on his own rudder pedals, observes full rudder travel on the ECAM. Touch the pedal's disconnect button, then the left rudder pedal to start the rudder check.
Please try again. Please try again.
The captain also checks for full and free movement of his own side stick and confirms the side stick controller against the ECAM flight control page. This is a silent check. The first officer sets the pitch trim from the load closeout data and observes the setting on the ECAM flight control page. In addition, rudder trim is confirmed to be at 0. During the takeoff roll, control deflection is in direct proportion to side stick movement. When takeoff power is applied, half travel forward side stick input should be applied to prevent the nose from pitching up. At 80 knots, gradually reduce this pressure to reach stick neutral at 100 knots. Routine use of lateral inputs to counter the effects of crosswind is not recommended. For crosswinds of over 15 knots, small amounts of lateral inputs may be used to maintain wings level. Too much results in excess spoiler deployment, which has the effect of increasing the tendency of the aircraft to turn into wind, reducing lift, and increasing drag. At VR, smoothly rotate the aircraft into the pitch command bar. At liftoff, as the aircraft transitions to flight mode, any lateral inputs used to counter the effects of strong crosswind must be relaxed to prevent the aircraft from rolling and to maintain wings level. This ensures a smooth transition to flight mode. Remember, in flight, lateral side stick inputs demand roll rate. When the acceleration altitude is reached, the flap slats are retracted. If takeoff was performed with flaps 2 or 3, select flaps 1 at F speed, the minimum speed for flap retraction, then select the flaps up at S speed, the minimum speed at which the slats may be retracted. If takeoff was performed with flaps 1 plus F, they are selected up at S speed. Touch the flaps lever to select the flaps up.
Please try again.
Once the flaps are up, the PNF announces flaps up. The after takeoff check is then requested by the pilot flying as soon as practical after the flaps are up. The PNF disarms the spoilers by pressing straight down on the speed brake lever. Disarm the spoilers, then touch the right arrow to continue. FMGC computed speeds default to flaps full. If a landing in Config 3 is desired, line select Config 3 on the MCDU Performance Approach page so that all FMGC computed speeds displayed are for the correct configuration. Line select Config 3. Also, on the overhead GPWS panel, select Landing Flap 3 to prevent nuisance flap warnings close to the ground. GPWS Flap 3 is displayed on the ECAM memo section. Select Landing Flaps 3, then touch the right arrow to continue. In a managed descent, if the aircraft becomes high on the profile, the message More Drag is displayed on the PFD. Extend the speed brakes to the 1/2 position until the profile is regained. On approach, the pilot flying calls for flap selections at the appropriate speeds. At green dot speed, select flap 1. In managed speed, the aircraft decelerates to S speed. Touch the flap lever to select flap 1, then touch the right arrow to continue. When flap 2 is selected, the aircraft decelerates to F speed. Touch the flaps lever to select flaps 2. At the appropriate time, the pilot flying calls gear down. Landing check. The PNF arms the spoilers by pulling straight up on the speed brake lever and reads the landing check. Touch the speed brake lever to arm the spoilers, then touch the right arrow to continue. Touch the flaps lever to select flap 3 and decelerate towards V-app. If the flaps full landing was planned, select flaps full. At approximately 20 feet, perform the flare maneuver by pulling back gently on the side stick to counteract the induced pitch down input. In a crosswind, the preferred technique is to use rudder to align the aircraft with the runway. If the input is gentle, very little, if any lateral control is required. Remember, side stick input in flight demands roll rate. At touchdown, gently lower the nose. The ground spoilers will extend, if armed, when the aircraft touches down and the thrust levers are reduced to idle. The PNF confirms ground spoiler deployment on the ECAM wheel page, which was automatically displayed upon gear extension. If the ground spoilers do not extend automatically and the landing was made with flaps full, they cannot be extended manually. If the landing was made with flaps 3, it is possible to extend the flight spoilers only by moving the speed brake lever aft. The after landing check calls for the flaps up. Slats flaps should be left in their landing position if the approach was made in icing conditions or following a landing on an ice, snow, or slush-contaminated runway. Touch the flaps lever, then the right arrow to continue. Disarm the ground spoilers by pressing straight down on the speed brake lever. In this lesson, we have discussed configuration safety check, cockpit geographic check, after start, before takeoff, takeoff, after takeoff check, descent, approach, landing, and after landing. In this lesson, we will discuss the following ECAM messages: ELAC 1 fault, ELAC 1 and 2 fault, flaps locked, stabilizer jam 1, stabilizer jam 2, side stick fault, left and right elevator fault. A fault in a single flight control computer requires that it be switched off, then on again to attempt a reset. The other computer assumes the functions of the failed computer, except for a sec failure where the associated spoilers will be lost. Caution: do not reset an ELAC if uncommanded maneuvers occurred during the flight. Touch the right arrow to continue. The failure of both ELACs or FACs, or all three secs, again requires that they all be reset, and if unsuccessful, the aircraft will be in alternate law, with associated protections lost. Touch the right arrow to continue. The flaps are currently selected to and indicating config 1 in flight. Touch the flaps lever to select config 2. Recall that, due to flaps or slats asymmetry, runaway or uncommanded movement, the wingtip brakes are activated and the flaps and or slats are locked in their current position. The wingtip brakes can only be reset on the ground. In this example, the flaps have locked between positions 1 and 2. The flaps locked caution is generated along with the master caution and single chime. ECAM advises that the wingtip brakes are on and displays the maximum flap extension speed for the current flaps lever position. This speed is also represented by the red and black max speed strip on the PFD speed scale. Clear flight controls by pressing the Clear button on the ECAM control panel. The status page indicates that flap 3 is to be used for landing. The approach speed additive is added to the VLS speed as displayed on the MCDU approach page and is manually entered by typing it into the scratch pad, then line selecting it into the VAP field. The landing distance must be increased due to the higher approach speed and loss of aerodynamic braking from the flaps. If a diversion was necessary, consider increased fuel consumption to the diversion airport. Refer to FCOM 3.02.10 Operating Techniques, which gives landing, go-around, and diversion procedures and fuel consumption guidelines. Clear status by pressing the Clear button on the ECAM control panel. With a jammed stabilizer, the ECAM procedure recommends checking the manual pitch trim and, if it is available, trim the aircraft to maintain neutral elevator as indicated on the flight control page. Alternate law becomes active, and the autopilot is not available. However, on the A320, control is much easier than on a conventional aircraft because, in alternate pitch law, the flight control computers will deflect the elevators in order to maintain 1G with a side stick neutral. Clear flight controls by pressing the Clear button on the ECAM control panel. Flaps 3 is used for landing, and if manual pitch trim is not available, landing gear extension is delayed until the flaps are in config 3 and the speed is reduced back to VAP. This is because once the landing gear is down, direct law becomes active, and although the previous elevator position is maintained, any further speed and configuration changes would require constant side stick pressure. Control forces, however, will be light due to the lack of an artificial fuel system. The approach speed must be modified to VREF plus 10 on the MCDU approach page, and a landing distance factor must be applied to the landing distance. Whenever this factor is not displayed on ECAM, it can be found in FCOM 3.02.80 Miscellaneous Procedures or in the QRH. In-op systems are listed on the right-hand side of the status page. Attitude, overspeed, and alpha limit protections are not available in alternate law. Clear status by pressing the Clear button on the ECAM control panel. If the pitch trim wheel is jammed, the ELACs may not detect the failure. There will be no ECAM warning, and normal law remains active. The only indication of a problem may be that on the ECAM flight control page, the elevators remain deflected. The procedure can be found in FCOM 3, Abnormal and Emergency Procedures, Flight Controls. Disconnect the autopilot, then check the manual pitch trim operation, and if available, trim to maintain the elevator at the 0 position. If not available, use flap 3 for landing. A side stick fault is generated to warn the crew of a faulty side stick. It is triggered when a pitch or roll transducer has failed. Touch the right arrow to continue. With the loss of both elevators, only manual pitch trim is available for pitch control. As well as the ECAM warning, the message "Manual Pitch Trim Only" is displayed on the PFDs. Do not use the speed brakes because of the induced pitch changes, which may be difficult to control with manual pitch trim only. Clear flight controls by pressing the Clear button on the ECAM control panel. The status page outlines the approach procedures and reminds the pilot that pitch control is mechanical backup and roll control is direct law. Clear status by pressing the Clear button on the ECAM control panel. In this lesson, we have discussed the following ECAM messages: ELAC 1 fault, ELAC 1 and 2 fault, flaps locked, stabilizer jam 1, stabilizer jam 2, side stick fault, left and right elevator fault.